Alright, picking up where we left off, we're back on 15.10. CaCO3, which is a solid, that makes CaO, solid, plus CO2 gas. Now it says that delta H is 132 kilojoules. Well, that's positive, meaning it's endothermic. So that 132 kilojoules goes on the left side. Okay, if it was negative 132, it would go on the right side, but it's positive, so it goes on the left. So part A says, what will happen to the amount of CaCO3 if the temperature is raised? If the temperature is raised, it shifts away from the side with the energy. So it shifts to the right, away from the energy. CaCO3 then will decrease because it's on the back end of the arrow. Okay, remember, think of that arrow as a hose. Okay, part B says, what will happen to the concentration of CO2 if the temperature is lowered? Well, if the temperature is lowered, the reaction shifts towards the side with the energy. Okay, so if that's the case, what will happen to CO2? Okay, well, CO2 is on the back end of the arrow, so it will also decrease. So temperature and pressure are really easy. On pressure, add up gas moles. And on temperature, just look at the side with the energy. You got to remember that if it's positive kilojoules, it's a reactant. If it's negative kilojoules, it's a product. Okay, and then just draw your arrow. Think of that as a hose. Okay. So that is Le Chatelier's principle. So we have completed the first 4 pages of the notes. All right, and we will just move on. And go to page 5 of the notes. Okay. So page 5, we kind of shift gears. We're still calculating K's, but this is called acid-base equilibria. All right. So an acid ionization reaction, let's say we have HCl, and it's aqueous. What's going to happen when it's dissolved in water is that an acid will split into its ions. So it'll split into an H plus ion and a Cl minus ion. Okay. For another acid, C2H4O2, that's acetic acid, it will split into an H plus ion and a C2H3O2 minus, an acetate ion. So the more readily an acid ionizes, okay, the stronger the acid. HCl is a strong acid because it completely ionizes in water. All right? But acetic acid, which is just vinegar, is a weak acid because it makes very few ions. It's weighted heavily towards the reactant. The larger the equilibrium constant, the stronger the acid. So if you have a K sub A, that's just the equilibrium constant for an acid of greater than 1, that's considered strong. All right, so K of A for HCl. So we're going to go back to, got a little space here. We have HCl, aqueous, splits into H plus Cl minus. So K sub A, it's just like the K that we did on your own 15.1. Okay, you're going to take the concentration of the products, so H plus times Cl minus over the concentration of HCl. So that's how the expression for K sub A for HCl. All right, you can do the same thing for a base. We call that K sub B. All right, so for a covalent base, all right, a non-hydroxide base, we'll get to that in a minute, a covalent base, we have, for example, NH3, okay, aqueous. We add liquid water to that, and the covalent base will take a hydrogen from that liquid water and take it to NH4 plus, and what's left of that liquid water is an OH minus. All right. So K sub B for that, we'll write this out, NH3 aqueous plus H2O liquid. You're always going to have this, that liquid H2O, if it's a covalent base. So that will make NH4 plus OH minus. All right, I hope you can see that. Okay, so K sub B in this case. Now remember, we don't use liquids in calculating K. So it's just going to be NH4 plus times OH minus, the concentration of that, over the concentration of NH3. Okay, we don't include the liquid water in that. Now just like for K sub A, a stronger base has a higher K sub B. Okay, so K sub B greater than 1 is considered a strong base. Now if you have an ionic base ionization, so an ionic base like sodium hydroxide, NaOH, okay, that doesn't need liquid water. It just splits into its ions because it's not covalent. Okay, it's ionic, so it'll just split into its ions. So we would have NaOH would split into Na plus OH minus. Okay, so K sub B would be Na plus times OH minus over the concentration of NaOH. All right, so really it's the same thing that we did at the very first of the chapter, except this time we're talking about acids and bases. Okay, so let's take a look at 15.11. All right, so this is on page 516, 15.11. That says, what is the equation for the acid ionization constant of HF? So all you got to do, first you got to get the reaction, HF. Now that is a covalent base. Okay, so we need to write that it's aqueous. These are always going to be aqueous. Okay. So HF, I'm sorry, it's not a covalent base. I apologize for that. Let me restate that. HF is an acid. Okay. So hydrofluoric acid. So that would split into its ions, H plus F minus. Okay, so it's balanced. You do have to balance them if they're not balanced. So K sub A will be concentration of H plus times the concentration of F minus over the concentration of HF. That's all there is to it. Now 15.12, we'll get to the bases there. It says, what is the equation for the base ionization constant of pH3? Now pH3 is a covalent base. So we have to add liquid water to that equation. So that pH3 is going to steal a hydrogen from liquid H2O and go to pH4. And what's left after you steal a hydrogen from H2O is hydroxide. Okay, now that is balanced. Okay, so we don't have to change the coefficients any. K sub B, then we're going to exclude the liquid H2O. So it's pH4 times OH minus over the concentration of pH3. So that is part A. The book doesn't give a part B, but I want to add a part B. I left you some space on your notes to give you an example of what is the base ionization constant for a hydroxide base. So let's take CaOH2. Okay, that's a hydroxide base. Now you don't have to have liquid water for that. It's going to split into Ca2 plus OH minus. Okay, now we need to balance this, so we need to put a 2 in front of OH, and it's balanced. So that affects our K sub B. K sub B will be Ca2 plus, concentration of that. You don't have to put the phases in this part. Times OH minus, and that's got to be squared, over the concentration of CaOH2. Okay, so that's how you do the formulas for K sub A and K sub B on acid and base reactions. Okay. So the very last part, last page of our notes, is the pH scale. Okay, that has to do with acids and bases. And you may have heard of the pH scale before. pH stands for potential hydrogen. pH is a measure of acidity. The range is 0 to 14. So 0 is the strongest acid, where 7 is neutral, so neither an acid or a base. 14 would be the strongest base. So you do need to learn all of these basic 5 categories in the pH scale. 0 to 1.9, a strong acid. 2 to 6.9, a weak acid. 7 is neutral. 7.1 to 12 is a weak base. 12.1 to 14 is a strong base. So for every 1 unit change in pH, there's a 10 unit change in acidity, right? It's a logarithmic scale, okay? So for example, an acid with a pH of 1 is 10 times stronger than an acid with a pH of 2, okay? pH also depends on the concentration. So a pH of 1 molar acetic acid is 2.3, whereas a pH of 0.005 molar HCl is also 2.3. HCl is a strong acid while acetic acid is a weak acid. So they have the same pH, but the concentration you can see is much stronger for the HCl. The pH of 1 molar hydrochloric acid is 1, okay? So that's basically stomach acid strength, and the pH is 1, so it's a strong acid. All right, so let's do, finish up the chapter. We'll do 15.13. And this is on page 517. So it says equal concentration of aqueous solutions are made with the following 4 chemicals. The pH of each solution is written next to the chemical formula. Identify the acids and the bases, and in addition indicate their relative strength. So C6H6OH has a pH of 5.1. Okay, so that is going to be a weak acid. Just refer to the table. KOH with a pH of 13.5 is a strong base. Okay. C2H7N has a pH of 8.7. That is going to be a weak base. And HBr, you might remember that one you had to memorize in chapter 10. That's hydrobromic acid. That has a pH of 1. So that will be a strong acid. Okay, so in closing, you need to read over the acid rain section. Okay, it shows you that's at the end of the chapter, the last couple pages. I'm not gonna cover that, so you can just read over that. But for the true, false, multiple choice on the upcoming test, read over the acid rain section in the book. Might need to also use that to answer the review questions. And I want to add one practice problem. We'll call it practice problem number 11. It may already be written in your book. But that question is, what is the base ionization constant for KOH. Okay, so give me the equation, the chemical equation, and then give me the equation for K sub B. Okay, so it didn't ask for, the practice problems didn't ask for a hydroxide base. It didn't give you a hydroxide base problem. So I just wanted to add that one. It probably already is written in your book because I've been doing it for years. So that completes the lecture for Chapter 15. You can now work all of the review questions and all of the practice problems.